Alright, so let's have a quick overview of the OEO console, which is the operator experiment oversight. We are already here plugged into an experiment. It's an experiment with 4 nodes, but we're only gonna play with a single node in the experiment, namely node number 2. And for this reason, we are here logged into the EVM of node number 2, so we can see what's happening in the experimental VM there. And we are logged into the OEO console here. Optionally, I'm gonna show you another way of seeing what's happening. And so this is, I'm gonna put math proxy running here. And also optionally, on the upper right, we have QGround control, which is gonna show us graphically what happens. So it's a different way of seeing what's happening in an experiment. You'll see much of the same information being repeated in all windows. So to start, let's start the OEO console. So I'm in the root directory. In the root directory, I type start OEO console. It shows me that there are 4 different nodes, 1 through 4, out of which 2 of them seem to be vehicles, which are both in stabilized mode. Stabilized is the default mode when the vehicle starts, so it's normal to be in that mode. They are both on top, are shown here next to on our field, sitting down at some small non-zero value of altitude. This is normal. This is a barometer error. It happens in reality as well, right? It's a bit off. Actually, in reality, it's more off than this. And in the upper left, we have the EVM. In here, I'm going to start the math proxy. So if we look here, screen minus ls is going to show 2 math proxies. And I'm going to connect to the screen of math proxy 2. So screen minus r math proxy 2. And what's going to show me is that I'm in stabilized mode, right? So there is nothing interesting going on there yet. And so the first thing I want to show you is that the OEO console over here has 3 windows. The top one shows various events. The second one here is the monitoring window. And in the monitoring window, you get to see what's going on with either the vehicle or the computer at this time, right? So you can see things like whether the vehicles are armed or what is the mode. But there are more things. So if you want, for example, to observe the voltage level of the battery, which is something always of concern in the real field, you can say add another field which is called vehicle battery voltage, and it's going to show you that the 2 vehicles have a fully charged 3S LiPo battery. Now this is a bit verbose, so you can rename this. You can say remap vehicle battery voltage to, let's say, just volts, and then it's gonna change to volts. And you can continue to add fields. For example, add vehicle speed, which we can rename to speed. Okay. And in case you wonder, this is due to GPS errors, right? So the emulation environment we have is accurate enough to show that GPS is never perfect. So therefore, the vehicle has the impression it's moving around on the ground. So this is normal to not be 0, even when the vehicle is disarmed and on the ground. This happens in reality as well. And another thing I want to show you is that because everybody may possibly want to monitor different things, you can save the current configuration with save config to some file name. I'm gonna just call it Mihai. And so later, if you come back and you say I want to restart the OEO console, but I want to see my settings, you can say load config Mihai, and it's gonna put your custom view for the OEO console. All right. So this allows you to see now. If you ask yourself, so how do I know what I can see? Two answers to that. The authoritative answer: you go to the AERPAW user manual, to 3.2, to OEO console, and in here, for the monitoring window, it shows you all the vehicle parameters which we're currently monitoring, as well as the computer parameters, including CPU utilization and which scripts are running and so on. It also shows you the command window that I didn't talk about yet. And the other way of doing it is you can say, can I see what the vehicle has as parameters? And you can say simply add vehicle. What that is gonna do, I'm gonna make this window big. It's gonna show you everything that the vehicle is currently outputting, all in one field. Right? And these are the latitude, longitude, and so on. So you can select something from here by typing add. By the same token, so you can say delete vehicle. And you can say what are for computers. You can say add computer. So for computer, these are the fields that are currently being monitored. And again, there is too much information for now, so I'm just gonna delete the computer fields. But you can add any one of them. Right? So this is in addition to the user manual. You can online see what are the things that we can monitor. Now, the third window is perhaps the most interesting one, because this one allows you to issue commands, and probably one of the most useful commands to issue is to start an experiment. And for that, if you look forward to how you set up experiments, in the root directory in here, right? So in the root directory, there is a file called startedexperiment.sh, which you need to edit, and I did already in advance, and I enabled the vehicle, and only the vehicle. There is no radio in this tutorial. And I put for the start vehicle script, I put the default predetermined trajectory with the default plan, right? So predetermined trajectory with the default plan. So now if I want to start, I could start the experiment from here like this, or better yet, I leave this alone. By the way, if I'm looking at what's running currently here, I'm gonna say screen -ls, nothing is running. But if I go here and I say in node number 2, I want to start experiment, then you see there is something happening, but not much. Nothing takes off, right? So the altitude is 0, the altitude is 0, nothing moves. And the question is why? And the answer is, well, if you look again what's going on here, now there is a process, which is the vehicle. Like, okay, let's go see what's going on in the vehicle. So screen -r vehicle. So retrieve that screen, and you'll see what happens is the vehicle is waiting for the safety pilot to arm. So what that means is that in reality, when this is a vehicle, the experiment does not start, or the vehicle script at least does not start. Now you can start the radios all you want without the safety pilot, but the vehicle will not start until safety pilot manually goes and arms that drone through its remote control. So how do you do that in development environment? Well, there are three distinct ways to do it. So you can go in ground control and you can arm it from here, right? You go to, when it's ready to fly, you go in and put it to arm. By the way, the mode cannot be land or RTL because it's not armable, but all other modes, including stabilize, it's armable, so you should be okay in that. So you can arm it from ground control and then sliding the so like this, press arm and then you slide this to the right and it's gonna arm. I'm not gonna arm it now because I want to show you the other options. Number two is you can go in map proxy and say arm throttle and press enter and it's gonna arm it. And finally the last one is through the OEO, you can say to arm, and at that point the script unblocks and starts to do its thing, and this thing starts by taking off at 25 meters. You see the drone actually gaining altitude. It gains altitude in here, gains altitude in here as well. In here it's as well, it says that it's gaining, it's gonna get to 25 meters or very close to that, and once it gets there, at ground control thinks it's 25 meters, reality is very close to that, and it starts to go through the waypoints. It goes to waypoint 1 and goes to waypoint 2, waypoint 3 and so on. So it's gonna start doing making its way. You can see here the drone leaning forward quite hard, getting to the next desired waypoint. Another thing that is you can see is that all three ways of monitoring the progress of the drone are in sync, right? It says that the drone is in guided mode, this is in guided mode, this is in guided mode. If I press enter, it's going to show me it's in guided mode. It's making its way. Another interesting thing is if you look at the voltage is lower than for the other drone that sits on the ground. This is the current speed. At the default speed, if I remember correctly, the default plan has the default speed, and the default speed is 5 meters per second. But since there are a lot of waypoints, it stops a lot at each waypoint, making its way from waypoint to waypoint to waypoint. So it actually never gets a chance to get to 5 meters per second. If we have a longer leg, it will get to 5 meters per second. Okay, so you see the voltage continues to drop, which is normal. It's also normal, incidentally, for the voltage to not have the same level all the time, right? So it's 2.9. It depends a lot on what is the current load on the motors and on the propellers. And now the drone is coming down, right? It shows here it descends at half a meter per second. It's 6 meters, 4 meters. It is now in land mode, right? So the last leg coming down, it changed to land. And here it shows that it's in land mode, and it's going to come all the way down, and then it's going to disarmed, and now it disarmed, and it shows here it changed from 1 to 0, right? So these are the things, the type of things, again, for a complete list of what you can monitor and other instructions you can issue to the drone. You'll find them on the OEO page. And again, so if you want to take off with this drone again, you cannot arm it when in land, so you need to go and put it in guided mode. Okay? So once it's in guided mode, it changes everywhere. Or it doesn't have to be guided, right? You can put it in stabilize, but it cannot be in land or RTL. Neither land nor RTL modes are armable modes for our drones. And this concludes the short tutorial on OEO, and I hope it will work for you as well as you expect.